Lesson 14.4 is evaluating logarithms. This is level 2 because it gets just slightly harder. We're still trying to just find the value of each log. And remember, a log is just a different way to write an exponential equation, if you'll call it. Let's ignore these two things for right now. Let's start with number 1. So remember, it'll say log with a subscript number, a number that's floated below or pushed down below. That's your base of your power. And I can still set this equal to question mark or a box or x, and I would say the base of my exponent's 3 raised to what power would equal 1 over 9. And so in that case, I'm noticing the 3 and the 9. I know how to make 9 because 3 squared would be 9. But to make this be 1 over 9, I would have to have to the negative second power. So what that does is it goes 1 over 3 squared, which would make 1 over 9. So this must be 3 to the negative second power to make that. All right, number 2. So yeah, this is log and then it doesn't have a number right here. That takes me over here at what's called a common log. A common log is a log that doesn't look like it has a base, but actually it does. Its base is 10. It's kind of like if I were to have the square root of a 9, and we talked about how radicals have an index or a little number here. We know there's a little 2 here because it's got to split this number, or what number times itself twice would make this. You know, we had a cube root. But square roots don't have to have that little 2. It's just all automatically assumed. Kind of like this log. It's automatically assumed if it's not there that it's a base of 10. So to rewrite this, I would say 10 to what power would equal 1/10. Well, these are already matching. The only thing I would need to do is have this 10 be to the negative first power, and that would sink that to the bottom to be 1 over 10. So my answer is simply negative 1. All right, number 3, we have a radical. So the first thing I would do is rewrite. Well, we'll save it, but I do notice those are both 4s. Let's put this equal to, I might start saying x. So let's rewrite this as 4 as my exponent to what power would equal cube root of 4. Now let's rewrite cube root of 4. Remember, it's to the first power, and since it's a cube root, that would be to the 1/3 power. So now all I need to know is, what does x have to be? Well, it has to be the same power, so that 4 to the 1/3 power will equal 4 to the 1/3 power. So I would say that my power needs to be 1/3. Okay, number 4, log base 2 of the 4th root of 8 would equal what? So let's rewrite it as 2 to the what power equals the 4th root of 8. I want both bases to be the same, so I don't like this being a 2 and this being an 8. So let's rewrite this. 2 to the what power? Let's say 8 is 2 times 2 is 4 times 2 is 8, 2 cubed. So the 4th root of 2 cubed is what I'm going to rewrite that as. Then I could rewrite this radical as a power, so I could say 2 to the what power would equal 2 to the 3/4 power. Just rewriting a radical as an exponent. So then my answer for this must be 3/4 because they have to match powers. So it's kind of just thinking about it. All right, now that takes us to a natural log. Natural log is going to be abbreviated ln of x. It also looks like it doesn't have a base, but it does. Its base is actually e. It's log base e. So anytime I see natural log of x, I really know it's a log with a base of e. Okay, so I could rewrite this as natural log base e of e equals what? Rewrite it, so that would be e to what power would equal e. And if you recall, e was a button on our calculator. We used it in the compound interest, the PERT formula, and e comes from hitting second this natural log button. And if I put in a power of 1, that tells me e is a number. It's about 2.72. It's irrational just like pi is, but it's a number. So e to what power would make e? Well, that would have to be 1, so that both sides would match. All right, number 6, natural log. So remember, I'm going to rewrite this, and I should have put log here instead of ln, but this is log with a base of e to the 5th would equal what? Rewrite it as an exponent. e to what power is e to the 5th? So this would have to be 5. Number 7, natural log, rewrite it as log base e of 1 over e to the 4th equals what? Rewrite it. E to what power makes 1 over e to the 4th? Well, you could flip this, bring this to the top by making our power negative. So what would our power have to be to match? -4. So you're really just trying to get common bases, kind of like we did on the first couple lessons, so that you can just try to make these powers be the same. And last one, natural log, so that's log base e of cube root of e. I already know that I'm probably going to have to rewrite this as a e to the 1/3 because I want these bases to match and have an exponent instead of a radical. So this is e to what power equals e to the 1/3. So my powers would be 1/3. And that's it.